Hello, Mr. Fry's algebra geometry class. I'm going over Unit 12 and Homework 5, probability, conditional probability. And I want to explain some of these. Remember the probability notes from earlier in the week. Those are going to come in real handy for understanding this. And remember, the probability notation is the probability of B given that A happened, that it already occurred. And the formula for that is, you have A and B, the intersection of A and B over or divided by the probability that A happened, okay? So with that in mind, let's take a look at number one. I'm going to go through the odd ones. Go ahead and do the even ones. You might sneak a peek on some of the even ones here. But I just want to talk about the odd ones because if I did them all, it would take forever. So for number one, you have a number from 1 to 40 is chosen at random and find each probability. Well, it helps to mark, okay, this is my B, this is my A. This is where I start, the PB/A, that PB/A. And then we're going to take those amounts and have the intersection of A and B over A. So even, okay, so even and at least 12. So you have both even and at least 12. I listed them all here for number one, all the even numbers here. So for them to be both, the intersection of even and at least 12 starts right here. So you just, you would take, and count all these, and you would end up getting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's where that 15 comes from, 15 over 40 of both of those happening, this part of the equation. Over the probability of A, my A is at least 12. So at least 12, well, 40 minus 11 gives you 29, so that leaves you with 29. So at least 12, you're going to have 12, 13, 14, 15. There's 29 more numbers. So that's where the 29 comes from. Okay? So that divided by that. You put it in your calculator like this. If you're having problems putting them in your calculator, I want to show you that also. So I have 15 divided by 40. Put it in parentheses. Okay, and then hit divided by, and more parentheses, 29 divided by 40, back parentheses, and hit equals. And then it'll give you your 51.7%. Okay, and I just went straight to, you could do the fractions, you could do the top and the bottom. I just went straight to decimal and percentages when I was doing this on my own. I want to take a look at number 3. It's actually number 3 here. Okay, so we want, this is my B, this is my A. So I use the formula, the intersection of A and B, where it's less than 25 and prime. So I listed all the prime numbers less than 40, because we have numbers 1 through 40. All the prime numbers are listed right here. So ones that are less than 25 in prime, so less than 25 in prime, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. That's where that 9 out of 40, okay? That's the intersection of A and B, okay? Divided by just my A, which is the prime numbers. Okay, there are 12 prime altogether, okay? That has already occurred. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 altogether in 1 through 40. Okay? And that will give me the 12 over 40. Once again, put it in your calculator with parentheses, and it will take you straight to the 0.75 or 75%. If you're asked to get the fraction, well, how do you do that? If you're asking how do you do that, all you have to do is the top 9 divided by 40. Let me do that. 9 ABC 40. Well, that doesn't help at all. You would just know that the 0.75 would be like 75 over 100, which would be, you could reduce that down to the 3/4. Moving on to number 5, we're working on these pennies, nickels, dimes, quarters. Altogether, I believe that there are 75. When I was doing this earlier, yeah, there's 75 altogether. Okay, so when we have quarter, not a penny, remember this is B and this is A. I know it's hard to see, but B, A, because I'm writing right over other letters, B and A. So I want to go back to this formula, the intersection of A and B. Quarter, not a penny, well, that's easy. That would just be the quarters. There's 20 of them, right? And then A happening alone, not a penny. So there's 15 pennies, so 75 minus 15 gives you the 60. Okay, so then you would just take those, put them in parentheses, and you can divide that and get in your calculator the way that you would want. Let me try this. Let me try it in parentheses this way. 20 divided by 75, back parentheses, use the ABC button, and then see what happens there. 60, if that will help you out, divided by 75. No, that won't work. Okay. Yeah, I thought maybe that would be an easier way to, go straight to the fraction. But this will take you straight to your decimal and your percentage. Going to number 7, penny, worth no more than 10 cents. So once again, this is your B and this is your A. And so we have the intersection of A and B is going to be 15 out of 75. And then A alone, worth no more than 10 cents, that's going to be the 55 out of 75. Number 9, a month of the year is chosen at random. What is the probability that the month has exactly 30 days, given that it is no later than August? Okay, 30 days and no later than August. So we have our B, and we have our A, if it's no longer than August. So we have the 2 out of the 12, those are the intersections of the 2. And then we have those that are with 30 days. So it's January, February, March, April. So we have April, January, February, March, April, May, June, July, August, September, October, November, December. So we got those. So that's going to be your 8 out of your 12. And you're just going to take these, once again, put these in parentheses and put in your calculator. That's going to take you right to 20.25 or 25%. A card that is chosen at random from a standard deck. What is the probability that the card is a spade or a king, given that it is black? Okay. So a spade or a king, that's going to be your 14 out of the 52. Black cards are 26 out of 52. And so you're going to just take this, and you're going to take that, and you are going to go ahead. I mean, you could, simplify those fractions, make them down into fractions, so it would be 7/13, or just take it and straight divide it, and you would get your decimal, and you could change that by moving the decimal 2 places to the right to make it into a percentage. Number 13, We are dealing with a bucket contains 60 polygon tiles. Of the tiles, 12 are triangles, 15 are squares, 8 are pentagons, 10 are hexagons, 6 are heptagons, and the rest are octagons. If a tile is chosen at random, find each probability. Okay, this is my B, this is my A. Okay, so the intersection of A and B is going to be 38 out of 30, has at least 4 sides and not a hexagon. And then not a hexagon would be, so you had hexagons were 10, so not a hexagon. Let me see, 25, 50 squares, pentagons, 10 are hexagons, 6 are heptagons, and the rest are octagons. Okay, so that's going to give you your, and I think this was a mistake because I think they're thinking heptagons. So this one actually should be, if it's hexagons, it would be the 50. So not a hexagon would be 50. So that's going to change. Okay, so we should have, let me see here real quick, 38 divided by 60, and that's all divided by 50, divided by 60, and 0.76. So it's just a little bit off. 0.76 or 76%. Because it says hexagons, and that would be 10 less than the total amount, which 60 would be the total amount. And it looked like they went with heptagons. So got to be careful of that. Number 15. So this is my B, this is my A. So the intersection of not an octagon and not a triangle would be 39 over 60. Just not a triangle. So there are 12 triangles. So that puts us at 48 over 60. So that one's good. So it'd be 13/16 or about 81%. Of the students at Wayland High School in the first quarter, 48% made honor roll, 30% had perfect attendance, and 25% both made the honor roll and had perfect attendance. If a student is chosen at random, what is the probability that they have perfect attendance given that they made the honor roll? Okay. That would be your 25% out of the 48, and when you just divide that, you get 0.52. In Mr. Berry's class, I think what we were doing, you made the honor roll, had perfect attendance, and 25 both made the honor roll and had perfect attendance. They did something like this, where it was 48 plus 30 minus the 25. Student is given that they made the honor roll. So that one would have been, let me see, 48 plus 30 minus 25, 53%. That was just using the addition rule. So that puts me at 53%, but I mean, you could stick with that one because that was on, that was in the Google Classroom. So go with that one. Number 19, we're looking at a group of students who were surveyed and asked if they use Instagram or Snapchat, and the results of the survey are shown in the Venn diagram below. If a student in this group is chosen at random, find each probability. So this is our B, this is our A. So uses Instagram, does not use Snapchat. Okay, so doesn't use Snapchat. You're going to have the 45 plus the 20. That's going to be our 65. And then uses Instagram, we have the 45. That's going to be the intersection. using the Instagram and not using Snapchat. So that's why it's 45 alone. So it's already done for you. So you just do the 45 divided by a 65. You could reduce it down to 9/13 and just get a little over 69%. I'm going to jump down to, and you could see 20 and some of these other ones, that's okay. I'm going to jump down to 21. A group of 100 students were surveyed and asked if they play sports or have a part-time job. Of the students surveyed, 40 play sports, 68 have a part-time job, and 22 both play sports and have a part-time job. If a student from this group is chosen at random, find each probability. Play sports, so this is my B, this is my A. Play sports and has a part-time job. So with that one, we're going to have 22 over 68. If you just go ahead and straight divide that, you're going to get with 32%. So we have the play sports. The intersection of those is the 22. So that's that first part that we were talking about. That first part, the intersection of the two. And then A alone would be 68, having the part-time job. That's why those numbers are there. And number 23, last but not least, has a part-time job, does not play sports. Okay, so my B and my A, the intersection of A and B would be 46. Having that, not playing sports and has a part-time job, that's what would be left. And then does not play sports would have to be 60 that were left over, because 100 minus the 40 gives you 60. That's where that number comes from. Okay, you just take the 46 divided by 60 and you get 0.7 with a repeating 6, so around 76%. Really hope this helps. Really confusing stuff. But, you know, if you just keep going back to the formula as I was doing on the even ones, on the ones that you're doing on your own, it should make a little bit more sense. Good luck.